Talking about power and radical functions. Okay, power and radical functions. It's kind of a continuation from the quadratic functions. We're going to talk about a few functions: individual, power, radical, rational, absolute value. I think that's it. So some of this may look familiar to you. So maybe it just be brand new. But by the end of it, you'll be able to graph and analyze the power and radical functions, as well as solve radical equations. Now, I know you guys did this back in Algebra 2, but we're going to be dealing more with a few more complicated ones, okay? Not the basic, square root of x equals 3 type problems. No, we're going to deal with some ones that are a little more, okay? So, a power function, okay? A power function is any function in the form of f of x equals ax to the n, where a and n are non-zero constant real numbers, like your quadratics, like your cubics, your quartics, so on and so forth, okay? So like x to the fifth, x to the third, x to the sixth, so on and so forth, okay? Now, a monomial function, what does monomial mean? One number or one term, okay? Is any function that can be written as f of x equals a, or f of x equals ax to the n, where again, a and n are non-zero constant real numbers, okay? So you guys have dealt with this before. Just want to clarify so you guys understand exactly what types of functions we are talking about, okay? Any questions before we go forward? All right. So, you have two different types of power functions. You have ones that are even and ones that are odd, okay? Even power functions are like x squared, x to the fourth, x to the sixth, so on and so forth, okay? Any type of even power function is going to basically have the same type of pattern and shape as your standard quadratic, okay? And we actually talked about quadratics on Tuesday, I believe, right? Because Wednesday we went over your test. So, the domains of any even power function is negative infinity to infinity. Yes?
Did you want us to fill in all the white stuff?
Yes, because I'm going to go over all of it. Okay? Your range of your most basic ones are 0 to infinity. Alright? And 0 is included, okay? Because usually that's where the vertex of some kind lie. Alright? You have x and y intercepts at 0, 0. It is continuous along the entire interval from negative infinity to positive infinity. They have y-axis symmetry. They either have a max or a min depending on if a is positive or negative, just like with quadratics, right? How do you know if it's going to have a minimum?
The a is negative.
Okay, so to be a minimum, is it negative or is it positive?
It's positive.
It's positive, okay, because then that means it opens up. If a is negative, then that means it's going to have a maximum, all right? Of course, it'll be decreasing on a particular interval, as well as increasing. Lastly, your end behavior. Your end behavior, which we talked about in Unit 7, deals with your limits as x gets really, really big or x gets really, really small. What is happening? And then small, I mean going towards negative infinity, x going towards positive infinity. There are your respective limits. If n is odd, that is x to the third, x to the fifth, x to the seventh, so on and so forth, okay? They're all going to follow the same type of end behavior, same type of symmetry, things of that nature, okay? Your domain and range is the same, negative infinity to infinity. It's continuous from negative infinity to infinity. You have
and it's odd. Like a, so if a was positive, that's like 4x 3 to the third power.
right, and that would follow this type of pattern if it was 4x to the third.
And if it was 3x to the third, then it would look like this one.
3x to the third would still look like this, because a is still positive. You said 4x to
Oh, so it has to be. Oh, it has to be a negative number. Sorry.
right. So 4x to the third would look like this, but negative 4x to the third would look like this. Okay, and then the difference between this is where A is positive, it's increasing the entire time. When A is negative, it is decreasing the entire time. Okay, so from negative infinity to infinity is decreasing or increasing. Okay, you have your respective end behaviors. This is the proper way to write end behavior. Okay, as a limit, as x approaches either negative infinity or as x approaches positive infinity. Okay, that means as x gets closer and closer to negative infinity, what's happening to my y's? What's happening to my y's here?
Approaching negative.
They're approaching negative infinity. And as x approaches positive infinity, what's happening to my y's? What's happening to my y's?
Positive infinity.
It's increasing up to what y value? Positive infinity. Okay? So on and so forth. Now, I'm going to skip a lot of this because you guys have already written it down, and I've already seen that some of y'all are already zoning out, so I'm going to keep pushing forward, okay? But do not forget about your symmetries as well.
So, with the answer odds that it's symmetric to the origin,
Correct?
but when they're even or they're even, they just look like quadratic, right?
Yes, it has y-axis symmetry, okay? Now realize the higher the degree goes, the more humps you may have, depending on how much it's been stretched or something like that. So do realize that does take into account. But the ends will still look like the ends of what a quadratic is.
Yeah.
Okay? So what we're going to do is we're going to analyze this particular function. We're going to describe the domain and range, the intercepts, the end behavior, the continuity, and where this function is increasing and decreasing, okay? Because that was one of the things that we should be able to do by the end of the lesson is analyze these graphs, okay? So we should already know what the ends should look like. Because is this an even power or an odd power?
Even.
It's an even, and you know that based off the 6, okay? So we kind of already know that with, even powers, it's going to look kind of like top 2, right? From the previous slide. Is A positive or negative? Positive, which means that my ends are going to point
Upward.
they're going to point upward. So honestly, without even graphing this picture, I can pretty much already know what my end behavior is going to be. I already know where I'm going to be continuous already.
How did you know it would be
Because this particular function, all your power functions are continuous along the entire interval.
even the next more than the exponent is odd?
Even when the exponent is odd. All right, so our end behavior. Let's go ahead and let's write that out. End behavior. The limit as x approaches negative infinity of f of x equals what? Positive infinity. Because remember, so as x gets really, really big, what's happening to my y's? They're getting bigger to infinity. And as the limit approaches negative infinity, what's happening to my y's? They're still getting bigger to infinity. And we also know that do realize, okay, you see how much space you have, yes? Okay? Please make sure you accommodate for that space. As for continuity, it's continuous from what to what? Say again? Okay, it's the rest of this too without graphing it, but let's graph it now. Okay? Let's graph this. What do you think? What's the best way to graph this? It's not a quadratic, so I can't, do that. I want to be specific. Say again? Pick points. Make a table. Okay? So, let's do that. Let's pick some points. Let's make a table. Which points? What are some good points? -2. Because think about it, you are raising this to what power?
Why do we have this? Why do we have this set up?
Because we're about to graph it.
Okay.
We are raising it to the 6, so we definitely don't want to make x like 5, because 5 to the 6th power is something really big, okay? And honestly, 2 to the 6 isn't too bad. You guys should be able to figure out 2 to the 6 without looking at your calculator, right? 2 to the 6th power, what is it?
64 times 2, right? 2 to the 5th.
64. Okay? What about negative 2 to the 6th power?
Positive 64.
It's still positive 64. Whenever you raise a negative number to an even power, it always turns to positive. What about,
Wouldn't you multiply that with 1 half?
you're right, we do have to take half of it. What's half of 64?
32.
So that's there. And then what about negative 1 to the 6th power? And then so multiply that by 1 half? So that's the same for positive. And what about 0?
0.
Very weird.
Wait. Anything to the 0. Oh, no.
So you have 0, 0. Go ahead and graph this. 2 and 32. Looking at this graph, what's your domain? What's your domain, Sarah? Very good, negative infinity to infinity. What is your range, Gabby?
0
Is 0 included? What are my intercepts, Caleb?
0, 0.
And where am I decreasing, Scott?
It's not decreasing.
He says not decreasing. Look again, remember we read from left to right, so if I wanted to trace along that curve at any point in time, does my pencil go down?
Infinity to 0.
Very good. And then where's it increasing? Sarita. So this is decreasing and increasing. Oh, you guys, you make your notes look a little nicer than mine. Questions?
Over.
Will you please decreasing, increasing view? Does it matter is it okay?
It definitely depends on the domain range. Other questions? Alright, do the next one. So talk about, give me some points you plotted to graph this.
Negative 2 and 1, 0. What?
Like points. So you said negative 2 and what?
32.
Negative 2 and 32? Uh-huh.
Negative 1, 1, 0, 0, 1, negative 1, 2, negative 32.
So this should have roughly look like this. Roughly. Okay. Definitely looking like your odd power functions. And you knew it should have been decreasing the entire time. Because of what reason?
A was negative.
Because A was negative. Okay, so we're decreasing the entire time. So that should have been from negative infinity to infinity. At no point in time do I ever turn up and go back.
Oh, really?
Let's see, what is the domain here? Megan, what you get? Forgot this thing. Yeah, so negative infinity to infinity. Negative P, what's the range? Good stuff. Intercepts. Maddie. 0, 0. Let's see. In behavior. Aiden. Say again.
Yeah. That's the limit, right?
Yep. The limit as, which one you giving me?
As it approaches
Infinity going to infinity, very good. And this is what type of end behavior? Left or right by that, I mean. It's left end behavior because it's going to the left. Negative infinity is going this way. And the other end behavior, as x to the positive infinity, Aiden, go ahead and finish that off. Very good. Continuity. No, we haven't. Continuity. Katie. Say it. Very good. Easy enough, right? Are there any questions?
Wait, what's the continuity?
Negative infinity to infinity, just continuous on the entire interval. No? Good stuff. Let's keep going. Now, when n is less than 0, meaning that it's a negative, okay? Such as x to the negative 1, x to the negative 2, x to the negative 3, so on and so forth, are undefined at x equals 0, okay? Because, anybody remember about exponents when you have a negative in the exponent, what it does? It makes it a fraction. And we know this. What is that? Say it a little louder.
Reciprocal.
It's a reciprocal function. And we know that reciprocal functions are undefined when x is 0. Okay? So even for the other ones, like x to the negative 2 is going to be what? 1 over x squared. Even that's going to be undefined at 0. Okay? So if it's undefined somewhere, it's continuous from negative infinity to infinity? No, it's not. At some point in time, it's not going to be continuous. Okay? What type of discontinuity are we going to have with a raised hand? What type of discontinuity are we going to have? Tyler?
A whole?
Not a whole. Gabby? Now removable. The last one? Infinite. Because it is a vertical asymptote that's happening at 0. Okay? Let's graph this. Okay? We'll graph it the same way that we did before. Okay? Let's make a table here. But I don't like it looking like that. How can I make it look a little nicer?
1 over 2x.
Careful. 2 over x to the 4th. Okay, the only thing that will move down is the x. So this is the same thing as 2 over x to the 4th, and that would be a little bit nicer when we actually try to plug in values here, okay? So let's make a table. And let's graph this one. Make a 2, make a 1, 0, 1, 2. Go ahead and plug in those values, okay? Plug in those values and get those points.
You divide the
Oh, is it that?
undefined
Is it
at
the one
0.
that goes?
It is undefined at 0.
So it goes up and then way up. Keep going.
Is undefined at 0, so we already know there's an asymptote there. And remember, with asymptotes, I should neither touch nor cross that line, okay? Now, when I plug in negative 2 to the 4th power is 16. 1 over 16, 2 over 16 is 1/8. So a really small number. What about when I plug in negative 1? Begin.
2.
2.
How did you know the acid? Oh, so because it was undefined at 0.
And when I plug in 1, I'll get the same thing I got when I plugged in negative 1. And when I plug in 2, I'll get the same thing I got when I plugged in negative 2. So this is what I have here. Negative 2, 1/8. Negative 1, 2. And then over here. Exactly. Since I have an asymptote, that means I'm going to get closer and closer and closer to my asymptote but never touch. And then over here, these are not going to continue to go and cross the x-axis, because think about it, the bigger that x gets, what's happening to the y's? It's going to get smaller. It's going to get like smaller into like the negatives, or it's going to get small like closer to
0.
Closer to 0. So this is going to, nice smooth curve. What's that?
So it'll never pass.
It's not going to pass, cross, or touch the x-axis. All even power negative even power functions are going to look like that. So x to the negative 2, x to the negative 6, they're going to all look like that.
If the odd would
Side by
be-
side.
If it's odd with negative, would it be on the upside? Be on the-
They will be across from each other. They're going to look like your classic reciprocal function if it's odd. So let's look at this. What's my domain here? Looking at this graph. Now that we have the graph there, raise your hand and you can tell me what the domain is.
Negative
A few people with a raised hand. Miriam?
You want me to answer?
Yes, please.
I'm not sure if I'm right, but negative infinity, 0, parentheses, union, 0 to positive.
You are correct. Good stuff. What about my range? Raise your hand if you can tell me what my range is here. Okay.
0, parentheses, to infinity, parentheses.
Very good. 0 is not included because remember, it's getting closer to it, but it's not actually going to cross it, okay? There's actually an asymptote there as well. Let's see. What about my intercepts?
None.
There are none. Because if I can't cross my y and I can't cross my x, I can't have an intercept. In behavior, the limit as x approaches positive infinity is what, Jonah?
Would it be positive infinity?
Careful. My x's are getting bigger.
Oh, so it'd be, wait, infinity?
Infinity, I think about to say something different.
Negative.
They're getting smaller, closer to the x-axis. What's the y value here?
0.
0. Okay? Because my y's are getting smaller and smaller and smaller the bigger the x gets. And if you did more values, you would be able to see that it would be getting smaller and smaller and smaller and smaller. Okay? What about as x approaches negative infinity? Ian?
Yeah.
It will be 0. It's doing the exact same thing, just on the other side. Continuity. Is it continuous?
No.
No. We kind of talked about this already. What type of? Thank you. It has infinite discontinuity. And am I increasing?
Yes.
From where, Sarita? Careful.
0.
0. Because what's happening after 0? Like after 0.
Oh.
What's happening after 0? Decreasing. So there you go. All even negative power functions, again, are going to look like this. Flip over to the next one. On you. Try to answer all the questions. Try to graph it. When you plug in -2, what'd you get?
Negative 1.
Negative 1, 4? And then when you plug in -1,
Negative 2.
when you plug in 0, so an asymptote there. When you plug in 1,
2.
and then 2.
1, 4.
So this one looks like our reciprocal function, yes? Our parent reciprocal functions, yes. 1 over x, 1 over x cubed, 1 over x to the 5th, they all look like the classic reciprocal function there. Domain, let me see. Ellie, what's the domain here? Very good, you are right. Yes, range. Let me see. Brooklyn, give me the range. Careful. To 0, and then Very good. Intercepts. Do I have any?
No.
No, just like last time. So I still have those asymptotes there. And let's see, what about my end behavior? As I'm approaching x from the right. Joanna, what am I approaching?
0.
Awesome. And the limit as I approach x on the left-hand side, negative infinity. Stephen A. Good stuff. And where is this function increasing or decreasing, Alex? Mm-hmm.
And then from decreasing from 0 to decreasing.
It is still decreasing. It's decreasing the entire time. There we go. Questions? It's decreasing the entire time. If A had been negative, what would have happened?
And would it be like
Flip the top and down.
It would have flipped. This one would have been down here. This one would have been up there. So then instead of decreasing the entire time, it would have what?
Increase.
It would have increased the entire time. Yes. Mm-mm. Because there's still that discontinuity there. So you want to break that up. Questions? Yes.
Alright, for the other one, if it was negative, it would just flip down.
Exactly. If this had been negative, then you would have had your branches, your hyperbolas, down here. And then it would have been decreasing it. All right. Few more. Getting you a little bit of everything. Recall from algebra 2 that x raised to the 1 over n indicates the nth root of x. Okay? And then when x is raised to the p over n, where p over n is in the simplest form, indicates the nth root of x to the p power. If n is an even integer, then the domain must be restricted to non-negative values. Okay? Non-negative values. So, if n is even, the domain is what? So, no, not negative infinity to infinity.
0 to infinity.
It would be 0 to infinity. Because it said the non-negative values. Now, could n be 0? Could n be 0? Am I going to put a bracket around 0? Am I going to put a parenthesis around 0? What do you think? Put a parenthesis?
Yes.
I would say bracket.
You would say bracket? Why?
0 is a negative. It's neither negative or positive. So.
Okay. We'll come back to this. We're going to graph these and then you'll see which one it should be. Odd. You have all real numbers. Negative infinity to positive infinity. And if n is negative,
Negative infinity to 0.
negative infinity is 0. We're going to graph some. Let's graph these, and then we'll come back to this, to be sure. Look at your next one. What do you think we should do? Make a table. And something that might help you. Don't want to say this. No, I'm not going to. I'll let you use your calculator on this one. Okay, but still use -2, -1, 0, 1, and 2. Use your calculator here. Get some values. Let's look at the graph. When you looked at your -2, what'd you get?
Negative 2.38.
What'd you do?
2.
2? Oh, you did 2.
Negative.
Negative 2.
Oh, -2. Okay. -2.
They're like up
Yeah.
the power.
Parentheses.
5 over 4.
Because you have to put the -2 in one.
Who said that? There you go. Yes. The calculator here reads, take 2, raise it to the 5/4, and then whatever that number is, make it negative. But you want the calculator to know that, hey, I need -2 raised to the 5/4. So then that way, it will give you an error.
We were supposed to get in there.
You were supposed to get an error.
I did it right, and y'all.
You'll get an error for both of your negatives. You get an error for both of your negatives. Excuse me. When you plug in 0, what'd you get? 1 and 2. 2 what? 8. So this is what we have: 0, 0, 1, 1, and 2, 2.38. Now, no, this is not a straight line. This is actually going to end up being kind of like a little bit of a curve. Because if I plug in 3, I'm going to get 3.95. And this is kind of curving out a little bit. Okay? So we see that when n is positive, or sorry, when n is even, my domain is 0 to infinity. Is 0 included?
Yes.
Yes, it is. Okay? So when I look at my denominator there, so my domain, I already know that, it's 0 to infinity. And my range is what? Bethany, what's my range?
0 to
Very good. My end behavior, I technically only have 1 in behavior. And so it's going to positive infinity. And where am I going to, Vivian? I'm going to infinity. Very good. Let's see. Intercepts. Do I have any? I got 0, 0. And am I continuous?
Yes.
Yes, I am. But only for the part where the function is actually like existing, right? And what's happening? Am I increasing or decreasing? Or both? Increasing. From,
0 to
there we go. Let's do the next one. Let's do the next one. Okay, so when you plug in -2, what you get?
3.03.
3.02? When you plug in -1, what you get?
4.
Oh, we plugged in 0.
Error.
Why would you? So that means that means what? At 0.
Fine.
Asymptote.
Thank you. When you plugged in 1, you got, and 2, you got 3.03. Okay. If I plugged in 3, what would happen? Because I need a little bit more, huh? 2.5, 8. So probably the same thing over here too, then, huh? What about when I plug in 4? 2.2. What happens when I plug in 5? Is it going to be something before 2? So it looks like I'm doing this number here. Did you guys get this?
Sure. Yeah.
What does the negative do to that x? Sam? Let me close together. side by side. Think about it. When we had x to the negative 2, what did that turn into?
Turn into
It turned into a reciprocal, 1 over x squared. So if we have a negative here, this becomes this, which means we still can't have 0 in the denominator. That's why there's an asymptote there. Okay? So you know when it asks us, huh? Yes. So when it asks us when n is negative, what's the domain going to be? What's the domain of this problem? 0 union 0 to infinity. Okay? Because basically it turns into like a reciprocal function there. So that's my domain. Negative infinity to 0, 0 to infinity. My range. What's my range? What is happening? The bigger x. What is happening? Is it really going to level out? Really is going to level out?
no.
It was 2/5 or 5/5?
If it's
2/5 like that? No, it's definitely gonna cross over too. You think it's gonna cross over 0?
no.
You don't think so?
They don't jump, but maybe. I
There's
don't
no way?
Maybe.
Let's see. I'm plugging 100. Plug 1,000. Nope, it's going to get closer and closer to 0. So what is my range?
0 to
0 to infinity. Let me see. Do I have any intercepts? No. Just like before with all of our other reciprocal functions, in behavior I have both. As x approaches positive infinity, I'm approaching 0. And as x approaches negative infinity, I'm approaching 0. And am I continuous? No. I have what type of discontinuity? Infinite with that vertical asymptote. And am I decreasing anywhere? Yes, from negative infinity to 0, I am decreasing. And what's happening from 0 to infinity? Huh?
Wait,
No,
you're
you got it
decreasing
back.
from 0 to
Sorry, not threw me off. With your power functions are anything like x to n, x to any power, okay? When n is even, it's going to have the same properties of a quadratic, both sides pointing up, pointing down. If it's odd, it's going to look like your cubic functions, where it's either decreasing all the way or increasing all the way. It's continuous the entire time, except when your power is negative. Then you're going to have some asymptotes, okay? And remember, if it is even and negative, it's going to look like this. When it's odd and negative, it's going to look like your classic reciprocal function, still with that discontinuity there. When you have what's known as a rational exponent, or basically a fraction as your exponent, as your power, if it is if n is even, your domain is from 0 to infinity, as we see in this particular example. If n is negative, it's basically with the asymptote very similar to those ones from before, where your exponent is negative. If it's positive, all real numbers. Didn't graph one like that, but that's okay, because we're gonna see in just a second. We'll graph one a little bit later. Questions up to here? We're just gonna be able to get through the graphing today. We'll save solving radical equations for next time. Exponential form is x to the p over n. It can be converted into a radical form if you did not remember that from algebra 2. Some of you guys did. Now, a radical function is a function that can be written as such, where n and p are positive integers greater than 1, but no common factors. If n is even, like 2, 4, 6, what do you think the domain is going to be? Bracket 0 to infinity. And if it's odd,
What made you say that?
what made you say that? Whoever said that?
Because of the other one, if the exponent is even.
Think about it. The one that we just did, if it is even, it's the same function. And if it's odd,
Could be
all real. Should you mind saying that to everybody? Because I was about to say that.
I was saying that's because n's the root, and so if the root's odd, then it allows the answer to be negative, but if it's even, it can be positive.
Exactly. Even roots. Think about it. Can you take the square root of the negative number?
It's not red.
Hmm?
It's not red.
No, I'm saying if it was even, could you take the square root of a negative number? No, you couldn't, because it would be imaginary. We're only dealing with the real axis here. So that's why you're bounded only to your positive numbers and 0. Okay? Here are your respective properties. If n is even, yes, we're from 0 to infinity. And if n is odd, we're from negative infinity to infinity. Okay, for your even functions, of course you have your x and y intercept 0, 0. It is continuous on the interval where it actually is. So from 0 to infinity, bracket, 0 to infinity. It has no type of symmetry, okay? Because it doesn't reflect or over the line or the point. It's increasing from 0 to infinity on the entire interval. It does have an absolute minimum at 0, 0, okay? The reason why is because it's basically an endpoint. You can have absolute maxes and mins at endpoints, but not relative maxes and mins at endpoints, okay? And since that is the lowest point on that curve, that's why it's an absolute minimum. And then lastly, you only have right in behavior, and that is to infinity. Okay?
So on n on, like when it's n on, will it have absolute minimum and maximum?
It would have no extremum because it is defined on the entire interval from negative infinity to infinity. Okay, so it's going to basically continue to get bigger and bigger and bigger. And if it's going to infinity, it can't have any absolute maxes or mins. It does have origin symmetry, as you guys can see. And this is an odd function. It's increasing the entire interval, and it does have left in and right in behavior. So, let's graph. Last two. Go ahead, it's on you. Calculator if you can. It's a square root, okay? You have a square root here, which means that your n is even or odd. Even. So that means your domain is going to be from 0 to infinity. Huh?
What do you mean that is odd?
The root, the index of the root. So basically, this is a square root.
Yeah.
And technically, you know, when we do square roots, we don't put like a little 2 on the inside. So I mean, that's what the square root is. It's that simple. So since n, which is the root, is a 2, which is even,
How do you know what to do?
because it's a square root. Square root is, it goes together with being squared, which is the number 2. So square root would be 2. There we go. What's the range? What you guys get?
0 to infinity.
0 to infinity, very good. Do I have any intercepts?
No. 0 to infinity.
In behavior, do I have both left and right or only one side?
Right.
So that's to infinity. So that is
Infinity.
very good. Continuous?
Yes.
Continuous. Add that together. Increasing or decreasing?
Increasing.
Increasing
Infinity.
from 0 to infinity. You got some big numbers, didn't you?
Yeah.
Except for 0 you got,
Zero.
and 1 you got,
7.07.
and after that it got really, really big. Now hopefully, anytime you get a decimal, you guys really do need to get into the habit of rounding how?
3 sig figs.
3 sig figs. So by doing this, you're basically telling me that the decimal you got was 7.071 or 2 or 3 or 4.
7.01.
7.071. Okay, so good. Good job rounding. What about here? Let's practice 3 significant figures. What was it?
20. It was just 20.
Oh, it was just 20? Oh, that's fine. All right. 3.
36.742. 36.7.
742, which means it would be 36.7. 4 would be at 56.6. And 5 would be at 0.01. Go down. So you have this basically, and then 2 would have been up here. Good stuff. Just like the other one. Here's one that we haven't done yet. It's odd. We haven't done this one yet, okay? But we definitely going to get it done before we leave, okay? So you got a 3-minute head start before I chime in. To do things like the 5th root or the 4th root or the 6th root, so on and so forth, you press whatever root it is, 5, 4, 6, whatever. So in this case, it's the 5th root, so you're going to press a 5. You go to math, and then you go down to option 5, which has x. And basically turns it into a 5th root.
So I didn't get that one half on the outside.
Okay, so then you just,
Parentheses.
yeah, you can parentheses a 1/2, and then there you go. Type the rest in.
Wow.
Alright, bring it back in so I can get this right before you guys go. These should have been the values that you got. These should have been the values that you got. And that is rounded correctly in your
Oh,
significant
wait,
figures.
to go from -3.
Okay? So basically, you are six, oh. Okay, so when n is odd, it is going to be from negative infinity to infinity for your domain. Okay? Your range is going to also be negative infinity to infinity because it's going to continue to increase. Okay? It's going to continue to increase past 1, past -1. And it's going to intercept at, in this particular case, somewhere between 1 and 2. I can go into detail more about it, but I am losing track of time. The limit as x approaches negative infinity, because I have both left and right in behavior, is negative infinity, because it's going to continue to get bigger. The right in behavior, as x approaches positive infinity, is going to also be infinity.
Wait, they both go to infinity?
No, the one on the left goes to negative infinity, the one on the right goes to positive infinity. It is continuous on the entire interval, and it is increasing the entire time.